Well, hi, and welcome to my shop. Thanks so much for joining me here. Today is the 18th of November, and feeling a little better about this radio now, because I'm pretty sure I got things sorted out on the band switch and the lights. And the rule is ignore the lights for now, and accept the band switch arrangement that I have written on here, which I'm pretty sure is correct. And what I'm going to do about the lights for now is I'm literally going to ignore them. Just ignore them. I worry about them later down the road. I still find it almost impossible to believe that the band lights can be wrong on this radio. I really, it's beyond the pale. I don't know. So, carry on with the alignment. Maybe there's more trouble in this radio too. I haven't found yet. There could be more. There could be more stories to be told in here. So, the alignment. You know what? I'm going to put the chart up on the screen here with the image, and we're just going to start working away on it. Okay, let's get the radio operating here before I get it operating so I know it operates. That's the primary thing. Every day I wonder. There we go. So that's the amplifier, my little amplifier coming on, making the hum. Volume. So again, there's no B plus on the radio right now. And I'm pretty sure that's, how can this be coming from my amplifier, my little amplifier, because there's a capacitor here. I don't know. Little DC in the volume control. That's what I would attribute that to, but who knows. Okay, on to other things. Let's make this guy work with the B plus here. Here we go. Okay, those are the typical settings. 25 milliamp, about 100 volts. Hello. I don't hear a thing. Okay, so I've switched it on to a band that maybe is silent. So let's switch back here. Sure enough. Okay, so back to the band we're going to do. How do I know that's the correct band? I looked at the light. I saw the light. I know the lights are backwards, and based on backwards lights, it's the right band, and for many reasons, I've got it on the right band now. What band is that? Let's look at the chart. Look at the chart. Now, I'm going to apologize ahead of time if I get this part you're looking at on your screen messed up, so I'm reading one thing and you can't see it. Let's just try this. There. So we're on number 6 here. So the 400 ohms is, I have a antenna simulator in the signal generator circuit that's taking care of this 11800. So you look at my signal generator there, it's at 10.4 because my past experience is when this radio is tuned to 11800 it picks up 10.4, but I'll bet you I didn't have it on the right band. I bet you that was just massive confusion, so we'll find out though. So this is the, let's just go up here and make sure. Frequency setting, dial, receiver dial setting. Okay, so the frequency on the signal generator is 11.8. The dial is set to, let me just make sure, 11.8. I'm sure the last time I did this, I was following the lights, so it would have been all messed up. You want to adjust the oscillator master manual switch position. Well, I think this is for the automatic frequency control, and setting it in manual to me is telling me that it is turned off, and I understand from looking at the circuit diagram that off means shorted. The switch is in the shorting position, so automatic frequency control should be disabled. I think that's the same as manual, for manual tuning. So now we gotta find oscillator 25 25 megacycle, 25 meter band oscillator is this coil here. How do I know that? In an effort to double check everything I'm doing, look at this diagram. You see the shape of these holes. This is the bottom of the radio. This is the top. Here's the plug. Here's the phono input. Right there it says L16, 11800, 25 meter band. Right. 25 meter band. Okay, and that one has to be this one. Wait a minute. It has to be this one. Oh. The one that's closest to the outlet, closest to the bottom. This one, this one, this one, this one, that one, this one. Pretty sure I know what I'm doing now. Let's go back up here. Okay, L16 maximum peak. Oh, there's a notation here. The notation is, if two peaks obtainable, use lower inductance setting, screw further out. So we're going to look for two peaks and then use the one that's further out. If there is two peaks. Two peaks. Okay, so our radio's on 11800. We hear nothing because of why? Because why don't we hear anything at all? Because the radio's way out of tune. For the first time, I've got the right band on for this frequency because I followed the lights before. So let's hunt around and see where maybe it's up at 11800 where it should be. It's really quiet. Let me check my yeah. A little bit of noise there. Yeah, everything's cranked up full here. 11.8, except for this. This is not full. My signal generator has another step to go. Boy, it's just as dead as can be. Is that because somebody aligned this thing to the moon? Is there a failure in here? Or is this not the band I think it is? Oh my god, this can't be the case. Okay, I'm now hitting this radio with of a signal. Just move my camera like this. Maybe it'll stay in focus better if I do that. Here we go. Oh! Something weird going on there. It's right on though. Why no modulation? Let's go fishing. Well, you know what? It's there. It's just so weak. Now I'm hitting this with a whopper of a signal. So I'm willing to bet now that this radio's been misaligned. And I am going to bring this thing to life. And could it be for the first time ever that this radio is going to operate right? Because it's been wrong since the day it came out of the factory. It's so hard to believe. It really is. Where's my tool? Okay, maybe we can do it with a screwdriver here. This one, is it? Seem a bit weaker. Doesn't seem to react much to that. This is an oscillator adjustment. The problem with this radio is not the oscillator. If it's tuning 11800 at 11822, it's not the oscillator that's way out of whack. It's something else. Let's skip the oscillator and leave it as it is. Let's look at these other ones. The next one is detector. C. Oh my gosh. C19. Right on time. No, wait. Let's go back and do that 11800 thing because of this peak issue. This peak about it could be on the wrong peak. I'm going to screw this radio up. If there's two peaks, then we should be able to get the radio to do this in two places on there. And if it's wrong, and it's on the wrong peak, the right peak is waiting. If it's on the right peak, there may be no wrong peak because this radio doesn't have two peaks. So logically then, yes, what? Really? Okay, cats are looking for attention here, but I want to get through this. So let's see if I can find another peak. I got the signal generator on full. This is the first time I've done this on full. Let's see what we find here. Was it? No, I went fishing with it on full. Well, you know, like there could be a second peak in here, but it's low enough I can't hear it. Well, you know what? What the heck? I can move this slug all the way out and stick it all the way back in after. And just exactly where is it here in this radio? This one, you know, it's out a fair ways. Can't say there's anything unusual about that. You wouldn't imagine these would actually protrude right out the back of the radio. If they were sticking right out the back, you might say, oh, that's gone too far. Just from looking at it, I think I need a different screwdriver here. So what we're going to try to do, I'm not sure what we're going to try to do. First find out if this is really the right okay, man. Okay, here we go. What are we doing? We want to, there's no, you know, this isn't even demodulating this signal. We're not hearing the 1000 hertz coming from the signal generator. Oh, son of a gun. That was my cat who has joined us up here on the bench now. Okay, buddy, you're looking the wrong way though. I'm trying to do this with my left hand here. Sort of got it. There we go. We're gonna back it up. There's no change in the radio. You're exactly the same output. Oh my God. Like that should, it should be just like tuning the radio. It should just disappear. I'm not going to put this back exactly where it was. What has gone wrong? Am I dumb? Did I pick the wrong one? How could I pick the wrong one? How could I pick the wrong one? Shadow, what's the answer to that question? No, the answer is you're distracted. You're dumb at times. Okay, so looking at the diagram now, it has to be this one right here. 25 meter band. We're on the 25 meter band. 25 meter band oscillator's doing nothing. There's no tone coming through here. What the heck is going on? So there's no tone, there's no detection of the signal. There's something showing up at 11800. What is it exactly that's showing up? I don't think this radio is working at all correctly. So which one of these coils is active? So none of these are making any difference. So I think what's happening is, with the powerful signal at 11800, the radio's front end sensitivity is what's coming through, and the local oscillator is missing on this band. There's no local oscillator here. That's my guess. So all that's really happening is just kind of noise at 11800. It's just making it all the way to the speaker because of the overwhelming signal I'm putting in, which may even be, I turn it down a bit, it may even be skipping over circuits. It's so powerful, and getting into wires later in the radio and coming out the speaker. No local oscillator. I really didn't figure this would be where I'd be getting to, but okay, let's check that out. What I'll do is I'm going to start up my SDR, which is hanging right here. The antenna part, I'm going to hang the coil here in the vicinity of these coils. That should be plenty good. Here comes the now I might have some trouble getting everything on the screen here. Let me just fool like this and see what I can do with that. Good. I can get this. My cat is purring like crazy over there. In case you can hear a little motorboat running. Okay, so the objective now is to look for a local oscillator signal. So let me just double check something here. Direct sampling Q branch, that's correct. Switch this on. We are on the 11 megahertz band, 11.8, so the oscillator should be 12.460. So 12.460, somewhere in here, and there's nothing there at all. Oh my gosh. Is there more screwed up in this radio than just the lights? Oh my gosh. So I know the local oscillator does oscillate on different bands. The radio will receive, even on broadcast, we've picked up stuff. So there's no question the local oscillator can operate. The question is it actually operating right now? But it's just nowhere near here? When so that would show up if I tune the radio and the sound. Well, there's really no sound coming out of the speaker, except when I have that 11800 thing happening. What I was going to say was I don't know what I was going to say. Should we go hunting for it? This local oscillator is actually running at a different frequency. That's a little bit tricky, but basically it's going to be in or above the shortwave bands. So we should be able to use the SDR fairly efficiently here to go hunting. So let's go hunting. Let's go see if we can find something. It should stand out. There isn't a lot of, see, there's something right there. Now what I'm going to do is I'm going to turn the tuner. You know what? It's going to move. Now I'm going to tune down, so that thing should go down. It's not moving. Okay, no movement, so that is not a local oscillator. Or the local oscillator is dead on this band. Let's go down further. Here's another shortwave band. This one is not on the radio. This band is not on the radio. Let's tune. I see nothing whatsoever. Usually there's all kinds of weird stuff on these when I do this. Now we're way down here. This is one of the bands. Okay, there's just nothing moving. No local oscillator operating. We'll shoot all the way up to 15 here. Look at this interesting interference. You can see it a little better on here. This is almost like I have a sweep generator bopping along in here. I see this in different locations in my house with SDR radios. Don't know what that is. A lot of weird stuff. Don't see anything. It looks like I'm tuning the radio. Well, you can see my hand tune the radio. Nothing at all. So and this is the band we think we're on right now. There's just nothing there. Let me wiggle the band switch. Could it be a dirty band switch? You dirty band switch. Where's my big powerful band switch tool? Here, you're sitting on the tool, cat. Okay, we're going to wiggle the band switch a little bit and just see if something pops on the screen there. And this radio is doing something weird between bands. I don't see anything. Okay, we're back on the what I think is the correct band. So dead on this band. Dead on this band. So what else is there that could be so far out as to just make this? No local oscillator. It's not. Why no local oscillator? Have I got something stupid going on up here? Have I pulled the grid cap on? Let's make this radio work on some band. I'll go on to the next one. I'm gonna skip this band. We can't align what we can't make work. So we might as well discover the whole story here. The 31 meter band is one back from where I am. One back from where I am. Okay, so that's turned on the light for the band we thought we were on. I'll just confuse myself and everybody if I say stuff like that. The band we are on now, by my reckoning, 31 meter band. 31 meter band. And we're supposed to do this at 9.6. Okay, 9.6. The light in your eyes there, cat. 9.6. Excuse me. Excuse me. There's that mysterious 10.4 again. So, Shadow, do you know what's wrong with this radio? Do you think I should give up on it? Are you having a good time today? Do you have any clue what you're doing? No. Oh, here comes the other one now. Come on in. Come on in. Join the club. Shadow's wondering what's going on. I'm wondering what's going on. Well, so what's going through my head here is what should I do about this? We have a strong signal at 10.4. A weaker signal at around 9.8. Seems to me it's been aligned on the wrong peak. Peanut. I think the sun might be shining right now, so he wants to go outside in the snow. Yes, there's snow outside from yesterday's big snowfall. I'm going to stop for a little while, play with my cats, and then decide what to try to do next with this radio here. Well, I can tell you honestly, I have terrible feelings about all this. This is just not proceeding the way it should at all. So now we're on the 9.6 megahertz band. That's the 31 meter band. That would be, and the diagram's right there. Gotta be that hole right there. Let me get a tone coming out of the speaker here first. Two peak thing happening here. Okay, now. This one. This is the one. This is the one. This is the one, Jim. Jim. Okay. You know what? These days, 10 minutes in my shop is too long. Okay, so what we're going to try now. What are we going to try now? Let's just double check things. So the receiver is tuned to it's supposed to be 9.6, isn't that what they want us to do? Yeah, 9.6 is what they recommend, so we're going to go there. 9.6. Whoa! Oh, multiple events just happened. A multiplicity of events just happened. Okay. Somehow, after blasting the radio with the signal from there, kind of accidentally, this radio came back stronger. As if I blew the dust out of it or something. That's a little weird, but what's not weird is that this is coming out correct. 9.6. Let me just back down the power. That's not far off. What was happening a moment ago? Let's go find some more peaks here. That's as far down as I can go. Nothing else. That looks like a half the frequency type thing happening there. You know, that would mean if there happens to be a signal on the antenna at 4.7 while I'm up here tuning around at 9, that signal would come through and it would be confusing. Especially that loud. But nothing else. It's just coming through mainly at 9.5 and that half one second. I'm not going to worry about it. So what was going on? I don't know what's going on. Let's just carry on here. We're getting somewhere. Don't ask too many questions when things appear to be going right. Or don't look a gift horse in the mouth. Okay, double checking where we're at. 9.6 here. Oscillator coil here. Actual frequency is just below. Go up there. We'll try to bring it in. Turn the volume down a little bit. Watch the meter now. Make sure I go in the right one. Nice strong sound. Signal level down. Doesn't get any better than that. This band appears to be good. 9.6 and down 9.6. Check mark. Go to the next band. The next band would be the next band on the hit parade here. 15. So 19 meter band. Funny sounds coming out of the radio. So 19 meter band. End of the run. That's a 19 meter band. So you can really see what's on that piece of paper. Hey, I've been watching videos on how magicians do their tricks. You know, it's really disappointing to find out what they're doing, because it's all a trick. And wow, they'll lie to you. Magicians, don't trust a magician. That's for sure. Now, so we want to go to 15.2 is where we're heading. So 15.2, I will dial that in here. 15.2. I'll dial it up here. Okay, I'll put the power up a little bit. And we should hear this. I don't hear anything. It's another dead band here. Okay, 15.2. What do we hear? Not a thing. More power. Okay, blasting its head off. Nothing. Go off hunting. Nothing. Band switch not making contact. Don't see it. No sound at all. Volume's up. They're up now. Let's try it again here. Well, it doesn't get much quieter than that. What do you do about this? You check to see if the local oscillator is there. Is the local oscillator present? Good question. So we'll tune this guy to where it should be. So right now the radio is tuned to 15.2, so it should be somewhere around 15.6, somewhere around in here. I don't see a thing. Normally the local oscillator would put a big signal up here. I'm going to wiggle the tuning a bit here, see what happens. Nothing moving at all. Nothing at all. How much you want to bet there just is no local oscillator again? This is one sick puppy of a radio. We'll go down to the next band that this radio has down here. No, nothing visible and nothing moving. And go down again. Nothing visible, really, and nothing at all moving. Nobody moving. Another one. That one's not on the radio. This is the other band. Nothing there. The local oscillator fails to operate on some shortwave bands. That's kind of what it looks like. It's just okay. Can't get anywhere with this one. So let's go back to this. Go on to the next, 6.1. This is not going well. 49 meter band. Next one over. So the antenna, I'm just noticing the antenna and the detector are really only done when you're doing the 11.8 megahertz. After that, it's all oscillator. So if somehow that detector and antenna are whacked right out, we can't adjust them because the first band is dead. I should adjust them with another band just to make sure they're okay. So I need a band operating before I do that. This is not going to be that band, I don't think. 15.2. Let's go on to the next. 49 meter band. First band after AM. Let's see if we're in the right spot here. So you go 1, 2. looked at the wrong diagram. That's 49. That's 31. Can you hear it? It just gets deader and deader as you go up. That's what's happening. So when you get to higher frequencies, there's no oscillator. That could be a weak oscillator tube or some other problem in the oscillator circuit. So 31 we hear. 29 sounds a lot stronger. It really sounds like failure to oscillate in the local oscillator at the higher frequencies. So on the 49 meter band, we tune in 6.1. Oh, this is that church. Kind of sounds like it's working. 6.1. 1 star. Okay, turn this down a bit. And get this way down to 6.1. Or up. So that's suspiciously close to 1,000,000 hertz. That's suspiciously close to double the IF. That's suspiciously close to misalignment. Because the radio is tuned to 61. Now we're getting 51. What happens at 61? Weak at 5.8. Oh my God, what is happening? Aye. So it does say if 2 peaks are available. It does give a warning. What if you have 3 peaks? 2 peaks possible. And what does it actually say? It says this is a 1 asterisk problem here. If 2 peaks obtainable, use the higher capacity setting. Pretty silent, aren't I? Because yeah, I'm adjusting a coil here. Oh no, C8. Okay, right, C8. And where would that be? Where would C8 be? Whoops, wrong way. C8, C19, C3, C8, 49 meter band right there. It's one of those guys I've got to adjust with the one of those weirdo capacitors. Okay, rotate this around. What's going on here? Yeah. Lots of cables getting caught on stuff. Ooh. So that earlier where I sent a strong signal through and all of a sudden this thing burst to stronger life could have been the weak connection in the back of my amplifier where I got a phono plug plugged in, which is kind of, well, of course it sounds fine now, thank you Mr. Murphy, but from time to time this has connection problems. And maybe that blast, you know, did that weird thing. It did the weird thing. So this is the adjustment. Don't hear any change. What exactly am I trying to do now? I am trying to make this thing say 6100 when the signal is maxed. So assuming this is the correct peak, I'm going to go up a little bit. Oh my gosh, it's all over the map in there. Let's do it this way here. I'm going to try to move the frequency through really slowly and just watch this meter and see what all it does, because it's not just going up and coming down. It may go off scale here when I go. Let's see if that works for us. Okay, so what I saw was it came up, hesitated, went up, went down, hesitated, and out. Apparently, someone needs attention here. Analog. Just when things are really getting interesting. Yeah. Okay, cats get a priority. Because they just get angrier and angrier at me. So, I gotta go play with the cat for a bit here. I'm coming. Okay, just in thinking about all this stuff, one of the things that comes to my mind is an open coil in the oscillator coil group, if I can call it that. What I'm thinking is, as you're progressing up frequency, as you're changing bands, I think you're encompassing more and more coil. I'm not sure. I have to study the schematic over this. Maybe it's the other way around. In any case, when you get to the third band up, third shortwave band up, things go dead because you've crossed into a coil that's got a that's open circuited or something like that. Something like that. I got to study the schematic enough to figure out A, if that hypothesis even makes sense, B, how do you even test for it, and because what it looks like is that this radio is not going to operate on the two higher bands. How it got into this state, I don't know. How you know, the mysterious light thing kind of suggests the band switch is all messed up, and this also suggests the same thing. And that would mean the radio never worked, which is that's just unbelievable. It's still in an unbelievable state. In the past, when I found myself in situations that just don't add up, it turns out to be things like a ground that's off somewhere that you can't see easily, a incorrectly installed wire or component, or any one of another thousand things. Now when it gets really weird, there's something really weird in the radio. Weird means unusual, and that's why it's really hard to sort these things out, because you're forced into parts of the forest you've never been in before. Okay, so that's my sort of trying to band-aid my ego here as much as possible. You know, one of the things when you're doing this kind of work, and lots of things in life, is maintaining the charge to go forward, and you have to protect it. If you don't protect your own charge, you're going to find yourself depleted doing this stuff, and you might even walk away from it because you just can't bear to do another hour of brain-teasing, unproductive nonsense. Is that what this is? Brain-teasing, unproductive nonsense. Yeah, it's good. Well, I think I'm going to end the video today reviewing the schematic here, and honestly I haven't got this figured out all the way, I'm pretty sure. You know, I'm into the area here I personally have a really difficult time with, and I imagine that's a common experience here, and that's these wafer switches or multiple contact switches in the radio and how they work. Now, the switches in here are shown in the broadcast position right now. But how these switches work, I've been staring at the schematic for quite a while. I'm just going to run through them. I don't think I have it right, because there just seems to be all kinds of conflicts in how they've depicted these switches. So why don't we start with this one, switch number 1. So when I look at this part of it here, and I see this big arrow, what I imagine is this connection here is moving forward as you advance the band. So this would be 19 meter band, this would be broadcast band. And I'm pretty sure that's the case. If you just come down here, you can see you're going into this unusual, relatively unusual arrangement here. It's different than all this. This is the broadcast band, and you can see it's in that position. So this thing just bopping up. That's easy. Now, if we look at this switch, which is part of this one, they're all the same. It's probably front side, back side of a wafer, maybe. Well, we see this barish thing here, as if all these arrows are connected together and slide together. So if you advance the switch one step, this whole thing slides up one. And that would put a short through here, And that makes sense, because actually, if you look at what it's doing, it's putting a ground here. It's eliminating this coil because you've moved off the broadcast band. So then if you go 2 bands up, now you'd have this, this, and this located here, here, and here. It doesn't much matter. These don't go anywhere. So all you're doing with this thing sliding upwards is you're just maintaining the shortwave band short here to short this coil out. That all makes sense. So here, this single line is sliding up, but here, this entire apparatus is sliding up. On the schematic, this is how they've depicted it. Okay, now let's go to the next switch. Let's try this one. There's the arrow again. There's the long pointer. Am I supposed to imagine this whole bar sliding upwards? So when if I were to snap the switch once, this would be contacting here. These wouldn't be contacting anything. This would be contacting this. And this part would now be contacting this. You know, I looked at this for quite a while. It doesn't make any sense at all that this bar is sliding. I think what would make sense is that this is sliding. The bar doesn't slide in the diagram, just this line. So snap it once and you would make this look short and make this look long and contacting here. That makes perfect sense to me. So now we have 3 different ways of depicting these switches already. Okay, as if it's going to get better. Now we got to ask some questions. Oh, what is this? And what is this? Have the answers down here where there's a bunch more. There's a bunch here, a couple down here. Now look at these ones. That's just a donut-shaped thing. But these ones have a little circle on the end of them. These ones have a little circle on the end of them. These ones don't. These ones have a rating. It says C8 something picofarads. This is one of those tubular, I shouldn't say tubular, those trimmers, those unusual capacitive trimmers with the rod that slides up and down through. Okay, see, these two are connected to nothing as they sit here on this diagram. Nothing at all. This one, well, it's not connected in down here. It's just sitting there. Okay, so we're on AM broadcast, connected here, coming down, going through this transformer arrangement down here. If we advance the switch once up to here, this wire, this line is now here. We are now using a capacitor as a trimmer on the 49 meter band. That's true. The 49 meter band is trimmed with a capacitor on the oscillator, whereas the rest of them are trimmed with cores. Even this one down here. Okay, that's great sense. So this is moved up to here. What's happened here? Is this moved? This is moved up. So this is moved up. This is now contacting here. So now you have this and this. You're now on short wave, and something's happening up into this coil. Okay, let's say we go another band. So we go another band forward. This line is now connecting here. This arrow is now up here. So now we have this one, and this one. So it's as if as you advance the band, you are incorporating more and more of these capacitors. It's quite possible it works that way. Quite possible. If you look at this one, you can see these coils are all connected together. So as you advance the band switch, you're incorporating more or less of all these coils. It looks like you're incorporating less the way they have it shown. So when you snap it once to here, you're utilizing all of them. You snap it one more time, you're now utilizing just these 3, one more time, just these 2, etc. It's quite similar. That can happen similarly in these coils, but it's not. These are selective coils. And this is very important for the hypothesis that one of these coils is open. It would be one of these. It would be, in fact, this one or this one. These are the two bands that appear to just not be alive, no local oscillator operating. So it's not a question of you are adding these coils in collectively as you advance the band control. You're selecting each individual coil. So to make the hypothesis work, if both bands are defective because of a fault in a coil, it's two different coils. Now I have, shame on me, I have had a radio in which there was a short circuit which was burning out coils, and I moved the band switch and just kept burning out coils. I burned out a number of coils. That was a long time ago, all fixed up now, but I learned my lesson about that. So it's possible that some circumstance occurred in which the coil was burned out and the band switch was moved because, hey, what happened there? We moved the band switch and this one burns out too. Move it one more time and maybe the wire's heavy enough. The heavy wire, it's the other way around. The heavier wire is up here on the radio. It gets finer and finer as you go down here. The lower and lower frequency needs more and more coil. So what about this switch then? So it looks like it's collecting these in as you move it up. It's getting away from this and feeding a signal after one snap back through this way. Understanding this is going to help with the troubleshooting of why those bands don't appear to have a functioning oscillator. By the way, one really good possibility here is this tube is weak and it just can't do the trick at the higher frequencies anymore. So I did test the tubes. The tubes all tested okay as I remember, but I'll be on my way to testing this one again. Find out what's up with it. Now, what about this switch? What are these things? No arrow. Looks like no arrow. It could be a poorly drawn arrow right there. Well, they look like switch contacts to me. And I don't know what else. This is a switch contact. Why would they show them like this? Because they're capacitors? But they put a value on it like they did here. And they'd show it, if there's these tubular ones, they'd show it with a little circle. And there's only 4 of these in the radio. And there they are. What the heck is this? What are these? These look like these, except they got the extra hole on the end. And there's no rating. So this is what's driving me nuts with this radio here. So if we assume that this whole bar is moving, and if we assume that this means when you click this one forward, this is then just nowhere. That doesn't make sense, does it? Because pictorially, they've lined this up to work pictorially. This would move to here. This would move to here. These would move here, but they don't make contact. Why are they even showing them? If you went one further, then this would be up here. This would be out where there's no connection. And these would just be coming along not reaching this. And what is this doing anyway? So this is doing one thing. In the broadcast position, this is closed. This circuit is closed. What's it doing? It's allowing these big coils here to operate in the local oscillator for the broadcast band. Advance it one step, click. Well, this is gone. So there's nothing. Goodness knows where this has come from. This is the cathode circuit. So the cathode circuit. But you gotta have this closed all the time. Cathode circuit's closed back. You can't open this. There'd be no cathode circuit. There'd be no cathode. Thought I got this right. Yes. Cathode. Oh well. From up here? No. A capacitor there. These are all hops in here. Yeah. So if you're hoping all of a sudden I'm gonna snap my fingers and go, and this is how it really works. I think I'm close, but an awful lot of questions here about how this really works. Yeah. So the prevailing theory then would be, actually I wrote down a few ideas here. oscillator tube, too weak to oscillate at the higher frequencies. I should put the oscilloscope on the output of this tube and double check that it's not oscillating, that I haven't fooled myself into thinking something's not happening when it is. Measure the resistance of these coils. This is a tricky business, but the resistance is written on them. See, it says 2 ohms there, and it says something here. Looks like point something ohms. It's tricky to read these very low resistance, but an open coil would leap out at you. Guess what? I've already done a quick test on these. Nothing open. The last one is the band switch on a couple of accounts. One could be the band switch is not making contact. I have not discovered the fact that the band switch is not making contact properly. That would certainly explain failure of the oscillator to oscillate. If you've broken the feedback loop in here because the switch isn't closing, no oscillation. How do we figure that out? I don't know yet. But that's another possibility, the band switch. And the last and the most horrific possibility, the set is worse miswired than I realize. Right now, I believe this light switch is messed up. It's actually backwards. But even that doesn't make a lot of sense, because on this radio, in this schematic rather, you're switching the power side of this output, but on my radio, it looks like you're switching the ground. So it doesn't match this even. I wonder if that's the source of the problem. Leads to some kind of misinterpretation. What I really imagine is some guy sitting in the factory back in 1930 whatever. The new guy. Oh, get him to do the light bulbs. Nobody likes that. Send him to the light bulbs. So he's sitting at a bench and he's preparing the string of light bulbs for these radios. And he's doing it wrong. And he does it wrong for quite a while. How nobody could catch that, I can't imagine. But is it only one radio that came out of the factory like this? Or am I just so messed up that I can't even sort out how the lights work on this radio? I don't think that's the case. I think step by step I'm getting on top of all this. So that's what's going to happen in the next video. We're going to pursue some of these ideas I have about what might be wrong, and just poke into this deeper and deeper. Well, it could also be component failures out here. It could be almost anything going on in here. But we'll just take it. What else can I do? One step at a time. So thanks so much for watching this video. Sorry it's not ending with, ta-da, it works. That's not what's happening here. But I think this is a curious enough thing. You might be interested in just following along as I try to unmess this thing. Have a great day.